Hi everyone! In this tutorial, we will use the official Modbus FB library to implement a Modbus RTU slave on the PLC. This program supports serial port configuration, segmented Modbus address mapping, and data sharing between register tables. Let's walk through the code step by step. First, confirm the Modbus library is added to your project. We'll use the server serial function block, which encapsulates the full RTU serial communication stack, including frame parsing, checksum, and slave response handling. Let's look at the variable definitions. Server 2 is the instance of the RTU slave function block. We also define memory arrays for Modbus data, discrete inputs, coils, input registers, and holding registers. These arrays store the PLC's local data that will be exposed to the Modbus master. Next, we configure which Modbus function codes the slave supports. Here, we enable all common read or write operations, read coils, read discrete inputs, read or write holding registers, and read or write input registers. You can disable unused codes to restrict master access for security. The table definitions structure is the heart of the slave's data mapping. It tells the server serial block how to split Modbus address ranges into segments and map them to PLC variables. Unum sections, number of segments for each Modbus table. Sections, pointer to the segment. Configuration array. This segmented design supports non-contiguous Modbus addresses and variable. Flexible mapping. Now let's break down the segment configurations. Each table section defines, with starting Modbus address. Unum datatems, number of addresses in the segment. Starter, pointer to the PLC variable. Unitatum size, bit width 8 bits for coils inputs. 16 bits for registers. Discrete inputs, map addresses 0 to 9 to add a discrete inputs memory in one segment. Coils, split into two segments. 0 to 4 gives a coil summary 1, 5 to 9 gives a coil summary 2. Mapping non-contiguous addresses to different PLC arrays. Input registers, 3 non-contiguous segments mapped to 2 different PLC arrays. Holding registers, addresses 0 to 6 map to a dedicated array, while 7 to 9 reuse impute registers memory to implement data sharing between input and holding registers. All configurations are complete. Now we call the server serial block to start the RTU slave. Key parameters. Zenable, enable the slave communication. United, slave station address here set to 1. IPO-RT, PLC serial port number, here COM1. Do baud rate, by data bits, a parity, a stop bits, serial parameters, must match the master device. Data model, pass our complete address mapping configuration. This single call initializes the entire Modbus RTU slave. We add a simple debugging logic here. This write request output pulses every time the master writes to the slave. We use this to increment a registered value, so we can easily verify write operations are working during testing. Now compile the project and download it to the PLC. When online, set Zenable to true to start the slave. You can use a Modbus master tool to connect and verify read-write operations. The mapped PLC arrays will update in real time, and the debug register will increment on each write request. The above is the configuration operation of simple series PLC as Modbus to slave. Thank you for watching.